my love for you people, and for the love of teaching forestry, Akash is here reporting for today. Indian Forest Community Service in charge, working under the regime, gonna become a deputy range forest officer. Coming to the first question, describe the method for the calculation of normal growing stock with the help of yield table. Determination of normal growing stock. A normal growing stock calculation in a clear filling system. The first one based on final mean annual increment, MAI. Capital I is equal to R into small I. The total growing stock is given by the equation, that is GS is equal to small I plus 2 small I plus 3 small I dot 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 plus RI. We can write this equation in other form of equation, that is GS is equal to I plus RI into R divided by 2. And this equation can be written as I into R divided by 2 plus I into R divided by 2. See, at the end of rotation, I into R is equal to capital I. So we can write down this equation as capital I into R divided by 2 plus I divided by 2. And after the harvest of rotation, year volume, that is I into R divided by 2 minus capital I divided by 2 is equal to I into R divided by 2. So look at this diagram. We have taken the age, year, in x-axis and the volume in the y-axis. As you can see, the rectangular box is nothing but this is the increment in the current year. So in a 1 year, that is in 1 year it is 1i, and in a second year the increment is 2i. Just like the same, for every year the increment changes. So that's what this diagram depicts. And the second one, that is a NGS calculation from yield table. In this, GS calculated in this growing stock calculated by adding volume of succession. Yield table gives data at 5-year intervals. Hence, smooth curves are drawn in order to get the growing stock value for intermittent years. Then the growing stock is calculated by planimeter or by counting the squares, but this is cumbersome process. Let A, B, C, D are the volumes at ages of n, 2n and 3n and 4n respectively. From yield table, then the sum of all age gradation is as follows. See, NGS volume can be given by an equation, that is n plus 1 divided by 2 into A plus B plus B plus C plus C plus D minus A plus B plus C. And at the end of the growing season, before harvest, the above equation can be simplified to, that is, the equation for NGS volume becomes n of A plus B plus C plus D divided by 2 plus D divided by 2. After harvest of rotation age class, again the NGS volume equation can be simplified to n of A plus B plus C plus D divided by 2 minus D divided by 2. And at the mid of the growing season, the NGS volume equation becomes n of A plus B plus C plus D divided by 2. So this completes the first question. Coming to the second question. What is compartment? Why is its study and description required when making working plan? Compartment. It is the territorial units of forest which are permanently defined for the purpose of administration, description, location and record. The compartment history describes the area, situation, boundaries, aspect, slope, rock, soil, altitude, overwood, underwood, undergrowth, quality of crop, density, regeneration, fauna, etc. Significance of compartment or in working plan are as follows. It prescribes the management practices according to the site conditions. It aims at sustained yield, which is the main principle for forest management. It gives the basic data such as physical factors of the locality, composition of forests, wildlife, etc. All this primary data is essential for forest management. In the working plan perspective, with objectives and priorities established, compartment become a tool for scheduling work, record keeping and measuring accomplishment. A simple division of the forest into compartments allows the owner to select a few of the better areas in which to work. By scheduling work in only one compartment each year, he can visualize the end as well as the beginning of the job. For larger industrial forests, compartment can be the basis for planning rotations and establishing cutting cycles. So this completes the second question. Coming to the third question, explain concrete and write the characteristics of good concrete mixture. Concrete is a paste of binding material, coarse aggregates and water which harden into a rock-like mass due to the chemical action of binding material and water. Concrete is composed of binding materials and aggregates. Binding material includes lime and cement. Aggregates are the inert materials added to the concrete for the purpose of increasing the mass and to decrease the cost. Fine aggregates include sand or screened stones which are used to fill the voids in between the coarse aggregates. It should contain less than 5% of organic matter. Coarse aggregates are greater than 4 cm in size, which includes broken stones, gravel, pebbles, and broken bricks. Surface of the coarse aggregates should be rough enough to give good strength. The proportioning for the concrete varies according to the methods used via arbitrary method, minimum voids method, trail mixture method. In arbitrary method, cement, fine and coarse aggregates are mixed in the ratio of 1:n:2n. RCC composed of cement, fine and coarse aggregates are in the ratio of 1:2:4, whereas for watertight purposes it should be 1:2.5:5 or 1:3:6. This completes the third question. Coming to the fourth question, what is progressive yield? How is annual yield obtained in a forest worked with the periodic blocks method? Progressive yield designates raising the productivity of soil and of the crop by silvicultural treatments, judicious tending, and enrichment of forest by changing the crop composition and by replacement of original inferior forest by valuable forest species. The principle involved in this is the production of maximum quantity of the kind of produce from the soil in the shortest possible time. Yield regulation in shelterwood system by periodic block methods. In this system, rotation is divided into number of convenient periods. According to the number of periods, total forest is divided into number of compartments. The areas allotted to various periods are called as periodic blocks, which may be equi-extensive or equi-productive in nature. This method is less rigid and yield is regulated by area, volume, and both area and volume. Final yield is obtained from matured periodic block over the period. The allotment of area to periodic block is done by 4 means. First one permanent, second one revocable, third one single, fourth one floating, fifth one stand selection method. First one, permanent allotment methods. Here it includes the regulation by area, and the second one, regulation by volume. We'll go through each one of them. The first one, regulation by area. See, the rotation is divided into number of periods. The area of the period block in a felling series is calculated as follows. Area of each period block is equal to A into P divided by R, where A is the area of felling system, P is the regeneration period, and R is the rotation. Period block may be of self-contained or scattered on the basis of the condition and maturity of crop in a compartment. Huffnall's variation or modification. Huffnall introduced a modification in the area determination for period block to obtain a sustained yield from all period block. According to this modification, the coop area is lesser for old age classes and more for less age class for a periodic block. The modified area for a periodic block is determined from the average age of the crop and rotation using the following formulae. The modified area is equal to area into average age divided by R divided by 2. The average age is determined by multiplying the area of each age class in the series by the average age of that class. Summing up the products and by dividing the sum by total area of the felling series, the annual yield from the periodic block is calculated using a quotas formula. Annual yield, that is y suffix a is equal to capital V plus P I divided by 2. The numerator divided by 2 is equal to capital V divided by P plus I divided by 2, where y suffix a is the annual yield, P is the period, and V is the standing volume, and I is the increment in the PB. This is applicable to the shelterwood system with a long rotation and not for annual coops or short periods. Second one, the regulation by volume. We use Hartig method here. Felling series is divided into period blocks. Felling series is divided into periodic blocks and volume of periodic blocks is equalized instead of area. Initially, age class allotment is made to periodic block. Then volume of crop to be allotted based on the yield table. The volume of first periodic block is determined by actual enumeration. If age class allotment does not give equal volume, slight shifting may be made. Third one, regulation by area and volume. Now coming to the permanent allotment method. See, this method was evolved by Kota and modified by Klipstein. In this method, periodic block has equal volume and equal area. First periodic block is allotted according to the age classes. Then preliminary equalization is made either for area or for volume. Then shifting is made to fix the other so that both area and volume are equal in all periodic blocks. The advantages, this system has combined advantages of both area and volume method. Disadvantages, this is the most rigid system. The crop response may not be in determined plan. Final felling postponed if no regeneration. Second one, revocable allotment. In this method, rotation is divided into periods. Correspondingly, felling series is split into periodic blocks. Inside the periodic block, compartments are allotted based on average age classes. Thereafter, necessary adjustments are made to equalize the area of various periodic block. More emphasis is given for the periodic block 1 for immediate allotment. The rest of the periodic blocks are allotted later and revised based on crop conditions. The periodic block 1 is allotted for regeneration on the basis of following priority. Number 1. Block where regeneration felling has not been completed in the previous period. Compartments damaged severely by insects, pests, fire, and other calamities. Compartments of mature crop with advanced growth. Compartments of mature crop without advanced growth. Third one, single allotment method. In this allotment, area is allotted to the current regeneration block and compartments are allotted in this periodic block only. The area and the period for the periodic block is fixed. The rest of the periodic blocks are not allotted considering the natural disturbance and the necessary revision at later. Fourth one, floating periodic block method. It is simple to single allotment method, but here size of periodic block and length of ration is not fixed in advance. Periodic block is allotted mainly to woods of over-matured or matured crops or areas where regeneration is started. The area of periodic block in normal forest is of exact proportion as crops are regular, whereas in irregular forest, the area is little more as it contains more mature crops and presence of advanced growth. The period and annual yield is calculated using the following formulae. P divided by R is equal to FPB divided by FS. Equation for P can be given as P is equal to R into FPB divided by FS. So the annual yield is equal to total volume of FPB divided by P. The advantages are felling is carried according to the silvicultural requirement of crops. No artificial period is fixed for regulation of felling. Disadvantages, it is applicable to normal forest and in abnormal forest it is little more difficult. Second one, it is not applicable for irregular forests. Fifth one, Judaic stand selection method. The concept of this method was originated from Kota and later modified well by Judaic in Germany. He believed that yield regulation over a long period was not accurate, and hence he concentrated yield regulation for a short period of 10 years. The main essence of this method is briefed below. Number 1. Forest is divided into number of compartments. The divided compartments are inspected and described well. Based on treatments, rotation and period are prescribed. Compartments are allotted to stands of importance, over-matured and mature crops, advanced regeneration, and other local factors. The size of coop is determined by considering area of felling system, rotation, and period. Annual yield is calculated from the total standing volume in the compartment in comparison to the period. That is, annual yield is equal to total volume in compartment divided by period. Advantages are: it is simple and more flexible method. Felling is carried out according to the actual condition of crops. It is applicable to regular crop even with the abnormality. Disadvantages: crops obtained are mixed in composition. Second one, sustainable yield may not be possible. So this completes the fourth question. Coming to the fifth question, describe the role of remote sensing and GIS in monitoring forest resources. See the applications of remote sensing. The first one, topographical mapping, geology. Second one, that is. Third one, soil mapping. Fourth one, forestry applications. Fifth one, terrain evaluation. Sixth one, land use or land cover mapping. Seventh one, agricultural applications. Eighth one, water resource application. Ninth one, environmental studies or flood damage studies. We'll go through each one of them. First one, topographical mapping. It refers to the mapping of surface configuration of an area. The common overlap between the two successive photos helps in topographical mapping. Second one, geology. The geological mapping involves both surface and subsurface mapping for mineral and other geophysical exploration. It is possible to do geological mapping for the following. First one, resistance to erosion. Second one, boundaries of rock types. Third one, topographic expression. Fourth one, faults and their patterns. Fifth one, drainage patterns. Sixth one, the vegetation cover. Third one, soil mapping. In soil mapping, photo helps in preparing a base map on which ground information can be inserted. Satellite image is more useful in soil mapping as it gives the soil information directly. Fourth one, forestry applications. The main applications of photo interpretation to forestry involves: first one, preparation of a base map. Second one, identification of tree species. Third one, quantitative measurements about the density of trees in a given area, height of trees, crown shapes, and volumes. Fifth one, terrain evaluation. Aerial photo aids to describe different terrain units or first one, position in landscape and association with the other terrain units. Second one, morphology, surface configuration and micro-relief. Third one, drainage pattern, texture and density, internal and external drainage. Fourth one, erosional features and the gully sections. Fifth one, land use and the cultural features. And the sixth one, vegetation. Sixth one, land use or land cover mappings. The term land use refers to the human activity associated with a specific piece of land. The term land cover related to the type of feature present on the surface of the earth. The land use or land cover types can easily be delineated on aerial photos seen under stereoscopic vision. Color photos enhance the features identification and hence give much more information. Seventh one, agricultural applications. The three major agricultural applications are: number one, crop condition assessment. Second one, crop type classification. Third one, crop yield estimation. Eighth one, water resource applications. It involves two types. One is mapping surface water bodies like streams, rivers, lakes, etc. And the second one, subsurface or groundwater potential. Ninth one, environment studies or flood damage studies. It includes number one, water pollution. Second one, deforestation and denudation. And third one, industrial population. Coming to the Geographic Information System, that is GIS. See, GIS is a computer-based information system which is used for presenting and analyzing the geographic features present on the Earth's surface and the events that taking place on it. Simply, it is a computer-assisted information system for the acquisition, storage, analysis, and the display of the geographic data in a desired manner. The applications of GIS are cadastral, topographic, and thematic mapping, surveying and cartography, remote sensing, image processing and photogrammetry, earth science and geographical applications, assist in decision makers to select the alternative resources, modeling for various applications, environmental pollution and natural hazard management, planning for various fields such as urban area management, transportation, architecture, conservation and landscaping, management and environmental impact analysis of natural resources. To locate hazardous or toxic factories, wildlife habitat and migrational study. So this completes the fifth question.